Hello everyone, good evening. Am I audible to you all?
Yes,
Yes, you are.
I can hear you. Yeah.
Thank you for joining the session, team. So on behalf of Credo Systems, I would like to welcome you all. So for the today's session, our mentor will be Mr. Santosh. So join the session throughout. At the end, you'll have a separate QA to clarify your queries as well. Also, you'll get the participation certificate. A form, registration form will be given to you. After 30 minutes, kindly share your details in the form as well. So without any further delay, I'm handling it over to Mr. Santosh.
Hey, hi all. Good evening, good morning from wherever you're joining. My name is Santosh. Um, Welcome to the session and thanks for your time. Uh, Overall, I have around 12 plus years of experience in IT, over 3 years of training experience in various domains like Linux, Azure, Terraform, and also there's a good experience and exposure to the penetration testing and red teaming. Hope you're able to hear me clearly and you're able to see my screen. Can somebody confirm?
Yes, Santosh, I can see.
Okay, thank you, thank you, thank you, thank you. Right, so I have expertise in various domains, not just Azure or Terraform. The Linux, I have done certifications in Linux. I have a leaning towards cybersecurity. That field interests me a lot. I have a passion to become an SME in various domains of cybersecurity. But of course, the other technologies I've learned to just augment what I have supporting. You can say that, right? So the today's webinar, right? So the title is getting started with Terraform on Azure. This is just the webinar title, but the course outline is kind of different. We'll go deeper into the Terraform when we look at the course content. So this is the scope of the webinar. First, we'll go through the introduction to Terraform. So why Terraform? Then maybe, I mean, you can say, it's like like Terraform intro should come after why Terraform. So I've just put it in a way that I could, in a way that I could. So introduction to Terraform, why Terraform, basic Terraform workflow, how Terraform works, how it looks at the resources, a sample demonstration of VM deployment. We'll look at a couple of VM deployments, one Linux, one Windows. I want to have a difference there, like one Windows and Linux. So you get to see both how it works, and how we create the VM. What are the things that we need to consider when we consider a deployment using Terraform? And the next would be the course outline, what we'll be taking up in the course. I'll explain you how we'll go through the course, etc. And finally, question and answers, or ask me anything. Like it's like anything. Like you can ask me about the course, or if any of these fields interest you, you can ask me questions, career questions, whatever. Right? If I know, I'll say yes, I'll answer. If I don't know, maybe I'll check and get back to you. Right? So quickly, let me jump into the introduction to Terraform. Right? So now these days, the cloud solution providers have become popular. Organizations are moving to cloud in a rapid fashion. Of course, it provides you a better visibility. It provides you high availability than what we might not be able to achieve in on-prem in some cases. It gives you good elasticity. It gives you a variety of options in the cloud. I'm talking about in the cloud. And of course, cost benefits we have. So everything, if you consider motivation to move to cloud, we have some advantages there. So okay, so let's fast forward and let's say, okay, now we are at a ready stage where we want to deploy the resources. Now it's just not one resource, or like few tens or hundreds. It's going to be much more than that, right? The resources are going to be in hundreds or sometimes thousands. If I want to count individual resources, it's going to be a lot, right? Doing this manually, right? Doing this deployment manually would be a real pain, in the sense that it is possible, but it's going to take a lot of time. It's going to take a lot of time. And manual approach leads to errors, leads to inefficiencies, maybe lack of oversight. You might not look what is in there, right? And you're just going to deploy. So many advantages of moving to cloud. Then comes your automation or the cloud deployment orchestration tool like Terraform, right? So that is where Terraform pitches in. It's an infrastructure as code uh, for your deployments, right? It could be, I mean, it is also used for on-prem as well. I mean, it's just a way to orchestrate deployments, orchestrate resources in a particular environment. As of now, there are many providers out there. Which is talking about cloud. You have AWS, Azure, GCP, DigitalOcean, and Oracle, etc. etc. There are many cloud providers. When I say providers, the plugins, that's what it means. Plugins that Terraform supports. So it does the job of auto orchestration, not just configuration management, right? The focus of Terraform. Now there is a difference between uh, why we use Terraform. That's important. We use Terraform to deploy the resources. That's important to understand, right? So Terraform is not one panacea or one thing that solves all the problem. No, it's just one of those major things that solves the problem is deployment of cloud resources. Easy to understand language. Yes, it is very easy. You'll see how easy it is. It uses HCL, HashiCorp language, configuration language, and easy portable to any provider. Just a few lines of change, you're there in the other provider and you can start deploying the resources. No need of additional configuration on the servers. Any deployments, it is agentless. Think of that. I don't want to slip into Ansible chef world, but it is agentless. You don't need any agent. You need to have proper authorization on the respective cloud solution provider to deploy the resources using Azure, using Terraform, right? So that's a bit of introduction to Terraform. So moving on to why Terraform, I've already explained. It has a multi-cloud, multi-provider support. It's a declarative language. So there are a couple of types of from the way we deploy, from the programming language or the infrastructure as code perspective. There are a couple of ways we can deploy. One is called a declarative mode. One is called imperative. Imperative is not here. It's only declarative. It's here. So one other is imperative. What is imperative? You are developing a code in Python, for example, right? You are going to execute everything. You're going to look at everything in detail and you're going to have that. I mean, you can go till a granular level and you can define what exactly you need. So you have a power of most of the things in a programming language like C, C++. But in case of infrastructure as code, Terraform, Ansible, it is declarative. You just say, what do you need? You just express your thoughts to deploy resource. A simple JSON block, a simple block. It's a block of code. Few lines to many hundred lines depends upon the type of deployment. You just say this is exactly what you need, and it's going to take care of all the API calls, all the resource deployment in the respective cloud provider. So that's how that's how user friendly Terraform is and easy to understand. What is important, the main advantage or the uh, reason why people go for Terraform is it's easy to understand and easy for deployment. It's just a few lines of code and you already have the resource. To deploy multiple resources of same type, it's even easy. Just one or two lines, your job is done. So if let's say I'm going to create two resource groups, it's just a matter of putting a line, one liner code, and that's it. You'll have two resource groups deployed. So it's as easy as that. And immutable infrastructure is there. So some of them are mutable, some of them are immutable. Like if you look at Key Vault, certain resources are going to be immutable. They cannot be deleted after a particular. It's a setting at Azure side, like Key Vault, certain resources, storage blob containers you cannot delete before a specific time, or even if you delete, you can restore that later on. So little bit focus we need to give when we look at resources like Key Vault, because we have to ensure that we decide or design it once and deploy it once. So we should not go back to the design state after we have deployed a Key Vault, right? Because the name needs to be changed. So the same Key Vault cannot be deployed even if it's deleted, because there is a purge protection. And that is state management. Very, very important point about Terraform. State management, right? Terraform maintains something called a state of, think of a state as a metadata of your entire infrastructure in cloud. So for example, this is a resource group. Within this resource group, you have these machines, these resources, etc. That's the metadata that Terraform maintains in something called a state file, right? It's the extension of the file is .tf state, TF for Terraform, right? So state management is an important concept in Terraform, and it maintains, think of state management as a memory. Terraform remembers what is there in your real world infrastructure versus what is there in the code, in what you've written versus what is there in the real world. It should match. The state helps there. It helps match both. If it's not, then it creates, deletes, updates the resources, etc. So it's called CRUD operation, CRUD, create, read, update, and delete. Of course, it just reads and it updates, creates. If there is a difference between what you've defined versus what is there in the real world, like what is there actually in your environment, right? So that's why we use Terraform. A basic Terraform workflow. If you look at the next step, okay, I understand Terraform. Now what next? So how does Terraform work? I mean, to start, Terraform is concerned about the working directory, right? In the working directory, you should define your resource and configuration file. It's called configuration files. In the configuration files, you will have the resource definitions. What is the resource that you want to deploy? That's Terraform initialization. So every time you start deploying, first step you need to do is Terraform init, Terraform initial. So what that means, first, it's going to initialize the working directory. Second, it's going to download all the required plugins. It is going to download the plugins. Now, what is plugins? Whatever cloud solution provider we are working with, for example, Azure, it is going to download the required plugins, which is matching with the code you have defined. Let's say you just want a resource group to be deployed. It's going to download the plugins, entire plugin of Azure RM or Azure Resource Manager into the working directory. That's what Terraform initialization does, right? This workflow will change a bit when we talk about Terraform Cloud. I'm not talking about Terraform Cloud right now. I'm just talking about a general Terraform workflow. But somebody who from this meeting who already know about Terraform Cloud a little bit, you know that we don't do Terraform init. It does it backend automatically. But this is what it does. Anyways, in the CLI, in the local install of Terraform, which I'm going to show you, it's going to, we have to do this manually. And we have to, I mean, in cloud, it does that automatically. So that's the difference. That the Terraform cloud and the local install of cloud install of Terraform is the same, one and the same. Just that the Terraform runs in a cloud machine. Here it's running in your local machine. That's the only difference. The concept is going to remain the same, right? To start with, Terraform init initializes the working directory. Then you go for planning. So Terraform plan. What is Terraform plan? Terraform plan is going to look at your code. It's going to create a plan of what is that you are going to deploy, right? Let's say I have 5 resource groups, 10 virtual machines as a code, right? It's going to look at all these things and create a plan. So the plan will consist of the operations which I just explained, CRUD. Either it's going to it's going to say, okay, you want to create X number of resources, or you want to update X number of resources, you want to delete is X number of resources. That's it. Or read anyways happens automatically every time you do a plan. Plan compares your technically plan compares your state versus what is there in the real world. If there is a difference, it's going to understand what is that you're going to create, what is that you're going to update, what is that you're going to delete. So that plan it gives you, right? It is always recommended, and a better way is to look at your plan before you go for Terraform apply. Very, very important thing. You need to understand the plan well, uh, then go for apply. Don't just directly apply. Where you can go to third stage like Terraform apply directly after init, but anyways, it's going to do a plan first and then go to apply, right? So plan is always important. It's the step we should not miss. And not only that, we should review the plan. That's important, right? So this habit of this method, if you follow this methodology, you will get used to Terraform a lot. And then sometimes you will think, okay, I don't even need to go for plan. I know what is going to be deployed. I'll go for Terraform. So for starters or for even intermediate who have been working in Terraform, it's always good to see Terraform plan, especially when you work in the production deployments, right? So plan is going to look at your state versus your apply. Assume that right now state file is empty, and it's going to look at the config files, and it's going to, let's say it's going to create a plan of the resources that you want to create. It's going to show the plan in the CLI. Then comes your apply. Apply is where the actual um, apply, meaning actual deployment of the resources are going to happen. So Terraform apply, as per the plan, Terraform apply will apply the changes whatever plan has uh, created, and Terraform apply is going to do the changes, right? Then what happens after the Terraform apply? I mean, Terraform destroy is just optional. You can use Terraform destroy to destroy the resources, but after you've done the apply, the state file gets updated automatically. It also updates the state file that it has deployed these resources as per the plan. And the state file, as of now, the state file and the infrastructure that you have are going to match, right? So that is Terraform apply and uh, what happens to the state. And finally, if you want to destroy, you um, use the command Terraform and then space destroy. This is going to destroy the resources that you have. This also creates a plan. Okay, this also creates a plan, but it is a plan of destroy. So you'll see everything that you'll see, it's going to delete. You'll see in the UI that these resources are going to be deleted. So this is the basic workflow of Terraform. This is how um, the overall steps that we have to follow, and the deployment of the resources in cloud. Very important point to take away from this slide is Terraform is concerned about just the working directory. So the working directory should have the configuration files. If you have the configuration files outside of the current working directory, it is not going to recognize that that configuration file, because Terraform is only concerned about what is that you're running in the current working directory. So that point should be very clear. And then later you can also use something called modules, which you can split the codes into different folders and let your module the module block refer to that particular folder. That is possible, but it's a little bit advanced topic, right? So that is all about your basic workflow of Terraform, right? Let's say that after apply, let's say that let's say the plan is all about creating 5 resource groups. Okay. Now let's say that you want to come back and add one more code lines to create one more resource group, the 6th resource group, right? So when you add the sixth resource group, you apply the plan and then apply. It's going to just recognize that as a create type of deployment, and it's going to just create that. Why? Because the rest of the file already matches the state and the real world infrastructure, right? So that is how it works. Now, if let's say I don't want a particular resource group. So we have 6 resource groups now. It's created. Let's say I delete lines of the resource group. What's going to happen? And if you do a plan, it's going to look at, okay, you have the state, you have the resource group, the 6th resource group in the state and in the real world infrastructure, but the config file doesn't have that. So it's going to decide that you want to delete it, and it's going to show the plan as a delete operation type. And then it deletes and when you do an apply, it's going to delete that uh, in the um, in the operation, in the apply, right? So it's idempotent in nature. Idempotent meaning that if you have deployed a resource and if you run that code multiple times, it's going to result in the same operation. It's not going to deploy multiple resources. One resource you deploy it once, it's going to remember. Even if you run it multiple times, it's idempotent in nature. People who work in Ansible, you will know this term, or general config management, you will understand. So what is idempotent? Idempotent means that you run it multiple times, it's going to result in the same result, which is nothing if it's already there. And this is also a declarative. This is the best example of a declarative syntax where you declare what do you need and you go ahead and apply, right? So quickly, I'll just go to the deployment of VMs. So here is my VS code, right? So I'll explain what this VS code is doing, right? I'll go file by file, so you understand. Don't get intimidated or overwhelmed with the number of files you have over here. It's as easy as it is. It's very easy. You can even have hundreds of files in a single working directory. It doesn't matter, as long as you know what you're doing. You know the basic concept. You know it's going to work, right? So firstly, the objective is to create a Windows machine, one Windows machine and one Linux. So that is all I'm going to do. So 2 machines I'm going to create. One is Windows machine and one is a Linux VM. That's our objective here, right? So for creating a Linux machine or a Windows machine, generally to create a machine, you have a dependency on the network interface card. You have the dependency on, optional dependency with the public IP. uh, of course, if you will, obviously you'll deploy a network security group, but that's still optional. But I'm just saying that is a dependency for the Linux VM. And very important, you need to have a VNet. That's a dependency. So you have to start from the place which needs to be created first. So first you need to create a virtual network. You need to create a network interface. Sorry, you have to create a virtual network. You have to create a subnet. And the next step is going to be create the virtual NIC or NIC, and then you will create the network security group, and then you refer those in the machine, like the virtual machine configuration code, right? So that is all here it's happening. So to start with, what I'm doing, I am calling an existing key vault. I have an existing key vault called AKV1211. Let me stop and start sharing so that my entire screen is visible to everybody. Just give me 1 minute. Just a minute, please. Yeah. So here is my portal. And if you look at, I just have a key vault, which is AKV. This key vault I created manually. I also wanted to give a taste of how you can import, or like not exactly import, but how you can call the existing resource in Terraform. That's also possible. So what that means, this key vault was created outside of the Terraform configuration. I'm not creating any key vault here. I created this key vault manually and I'm calling that to be included in the state. So I have to call that and perform it, right? This is what I'm doing. So this key_vault.tf file is calling the existing key vault. Then I am applying a key vault access policy. Why? My Terraform service principal that I'm using should have proper access to create a key, to delete a key, to add a secret, to delete a secret. So that's what is happening in this second step. So people who have worked in key vault or know, you'll understand that we will we need for access policy. So there are two types of like authorization in Key Vault. One is access policies, one is through Azure AD or Microsoft Entra ID. So this is an example of Vault access policies, right? So I'm adding the object ID of my current object, which is my Terraform service principal, and the permissions I'm passing is create script, create secret, delete secret, and purge, etc. Why I'm doing this operation, you'll understand in some time, right? Now, this is the first step I'm doing. Then I'm not going in the order. The files are not in the order. The next step, what I'm doing, I am going to something called random. This is a Terraform, like HashiCorp's own module. I'm creating a couple of strings that has special characters of length 10, because I need to pass a value as a password to the VMs, and I don't want the password to be hard coded. This is not the password. This is just override special. It is going to override the special characters with these characters. So nowhere in the code you will see I'm passing a password as plain text, right? So I'm creating I'm actually creating two passwords, one for Linux VM, one for Windows. So that's why I'm using for each, and I'm passing a particular value to this for each. And if you look at what I'm passing here, this is what I'm passing. I'm passing a list of uh, value. The list contains Linux VM's string and Windows VM string. So it's a list of VM nicks. So I'm passing that to the random block because it creates it because I'm creating now. Why I'm creating two passwords? Because I have two VMs. I have to pass the respective password to the respective VM. That's why I'm creating this random password, and I don't want to hard code the password in the code. Then networking, right? Then networking. Key vault and networking doesn't have any dependency. Both are independent. So I'm just creating. There's no dependency clause here unless you are going to create a private endpoint, right? So I'm not going a bit deeper. Don't want to make it a bit complicated, but there's no dependency between key vault and networking. Both can be independent of each other as of now. Now I am creating a virtual network because I need a virtual network. So that's correct. So that's what I'm doing here because I need the VMs to be created in this sub VNet and subnet. So I have to first create a VNet, and then I'm creating a subnet. Okay, then I'm creating a network interface. Why I'm creating two network interface? Because I want to attach the two network interface to the respective VM. So again, I'm using the same variable var vmnext. Now the beauty of Terraform is that you can add just one string you can add. Let's say third VM. And guess what? You don't have to do anything. It's going to create three VMs on its own. So let's say you want to create one more VM, right? So you just pass in the value here, third VM, and that's it. It's all going to create that. So no changes required except adding a particular item to the list over here, right? So networking, I'm creating a network interface, couple of network interface with single block. I'm using single block to create two network interface here. This is just one more network interface I'm creating. Doesn't have anything to do with the ones that I just explained. Just one network interface I'm creating. And I'm creating a network security group because I need a network security group. And I'm attaching that to the subnet. So I'm not creating two network security groups. I'm creating just one network security groups. And I am attaching to the subnet, one subnet. Right? If you look at how I'm attaching the network interface here. This is the code to attach the network interface with the I mean, sorry, I'm attaching the network interface with the security, with the network interface card. Yeah. So NSG I'm attaching to the NIC network interface. So I thought it's subnet. Yeah. So this is the simple network security group that I'm creating, and here using dynamic blocks, dynamic keyword is going to be used to repeat the nested block. So security rule is a nested block in network security group resource block. So let's say I have 10 rules to create. I don't want to repeat that nested block. Otherwise, I'll have to repeat this security rule 10 times within the uh, a network security group resource block, right? To avoid that, all I do is just create a network rules variable, locals variable, and I just pass in a list with dictionary as, or with map as items, individual items. So this is one map, this is another map. All I'm doing, I'm opening up 3389 port and port number 80. So this is also like you don't have to repeat the security rule block with the dynamic and content keywords. And you can always apply the tags, that's fine. And I'm attaching the network security group with the network interface card. That's possible. So even, I mean, it's just, you can also attach this to the subnet that I'm creating, just the block name would change. That's all, right? And now some people might have a question. Okay, how does Terraform understand the dependency? There are a couple of types here, dependencies. One is implicit, one is explicit. When Terraform encounters this line, okay, it understands that it needs to create this block first and then come here. So it's going to look at this line. Okay, you want me to, oh, so not this, not this, sorry, the line number 80. It's going to come to line number 80 and it's going to see, okay, you're referencing this block. Okay, let me go to that block and create the resource. It's going to come here and then it's going to create that resource. Now, the way Terraform deploys, right? It's a random in nature, not there's no specific order that Terraform deploys. Similar to Ansible Chef, where there's no order to the deployment of the resources. So you'll have to anyways uh, uh, specify the dependencies to the Terraform. And specifying dependency, there are a couple of types. One is implicit, explicit. Mostly we'll be looking at implicit dependencies, and there are scenarios where you need to have a explicit dependencies. There are scenarios, but mostly with this, when it encounters this line, I'm passing the names dynamically with the resource address. This is called a resource address. It encounters this line, it's going to go and create the resource group first, and it's going to come back here. Right? So this is networking code. Then you have providers. Providers is where I express, I mean, I explain to Terraform that I need to use the respective provider called Azure because I'm deploying the resources in Azure, and I specify a particular version. This is actually, this goes to the Terraform registry and downloads the plugins, right? And also, I'm not going to show, yeah, this is, you also have to pass in the values like client ID, client secret, subscription ID, tenant ID, arguments and values to the this block so that it knows that there is an XP. Of course, you need authorization and authentication in Azure to deploy anything. So we create a service principal or app object and provide the app object enterprise. Provide the app object subscription level contributor access, and then we hard code the values. There are ways you manage these hard values, how you want to hard code, but this is just a beginner way to do that. My question, people might say, okay, you are hard coding the client secret, not secure. Agreed. There are a lot other ways to solve the problem, right? Then you have provisioners. I've just commented out. It's kind of advanced topic. All provisioner is doing here. It's just creating a file in the destination, and it's going to create a file in the destination. Terraform can also operate within the servers. That's possible, but mostly we should restrict the Terraform only to deploy the resources. Going beyond the deployment IAC and getting into the configuration management domain is going to be a problem, because that Terraform is not designed to handle that. So just thing, you can also execute commands, remote commands from your machine, right? Then you have random module where you are going to create the random passwords or random strings. I'm creating a storage account just for demonstration purpose. Storage account is going to host these files, default.html and the script.sh because I'm using custom VM extension. Custom script extension is another thing that you can use if you want to, like during the deploy time, you want to install certain packages, certain applications. You can handle them through PowerShell or shell script respectively, and attach them as virtual machine extension, custom script extension. So I just have a block to create a custom script extension that's going to read the script from a storage account. That's it. That's all I'm doing over here with the custom VM extension. And what is the script? The script is all about creating a IIS web server. It's a web server component. I'm just setting a content of the file as this is a file name, and this is the file content. This will be applicable for the Windows VM. And if you look at in custom script extension, I am passing the Windows VM's ID. And that's it. Template file is it's a blank. It's not going to do anything here. So storage, I'm uploading the scripts, and there is the state file, right? And there is vars. So you can use variables to pass in the values instead of hard coding it, because you define it once and you reuse it at multiple places. So I'm defining what is the resource group name that I need to have, what is the VNet name I need, what is the VNet address space I need, what is the subnet information, like I'm creating 2 subnets over here. I'm creating the containers in the storage account. I'm creating a condition to state that I need to create 2 subnets. While I pass in the CLI, I can also modify this value. You can also override this value of 2 in CLI or in the there is something called TF-vars file. Now I'll quickly do a Terraform. That's it. And I think a WinVM, this is just a Windows VM code where I'm giving the name of the resource group name, location, all dynamically hard coded. Size also you can pass in the variable, but I'm just hard coding. And if you look at here, very important point, line number 7, admin password, I'm getting the value from the random password block. And the network interface that it should attach to, it should be provided with this notation, like the resource address and then dot the property of the resource. So source image reference I give here. And similarly, the Linux VM is here. Okay, so let me do Terraform init to start with. And it's all already downloaded, but if it's not there, it's going to download. I'm going to do a Terraform plan. Terraform exe is a local install or local download of the Terraform. There are various ways you can deploy in Terraform. You can use cloud, you can use Terraform local install. I'm just using local install for this demonstration. So this is the plan. It's going to say 15 to add, okay, 0 to change, 0 to destroy, because I don't have any resources right now, any of these resources right now in my environment. So it's going to, if you look at the plan, if you see, it's going to create a virtual machine. Like this is the details about it. It's going to create a virtual machine extension. It will be created. Like whatever resource blocks that you have, it's going to, you're going to see the names over here, the resource address of those blocks. Because I'm creating multiple containers, it's going to tell me what are the containers it is creating, because I'm using for each in the storage container block. Because I want to create 3 containers, I want to use 1 block. That's why. So let me do apply. It's going to ask me yes or no to continue. You can bypass it. Not recommended. Always verify that you are going to create these many resources, and I'm going to just say yes to the prompt. Yeah, it's going to ask a value. I'm going to say yes. it's going to accept only this. I think this is case sensitive. Not sure, but yeah. Other than yes, it's not going to ask. It's not going to. It's any other value you put. It's going to take as no, and that's it. So it's creating everything, but going in the order, not going random. It's going in the order. It's going to create the resource group first because that's the most basic thing. If you look at our main.tf, this is where I have the resource group creation. Yeah. So I'm creating a resource group name called, what is the resource group name? 𝗓𝗪𝗀. Right. So let me go to the terminal. Let me go to the portal. And 𝗓𝗪𝗀 is already here. If I go to 𝗓𝗪𝗀, you will see that I have got these machines created and resources that are getting created. So, I mean, it's creating, but immediately you'll not be able to see. It takes some time to reflect in the portal. All right. Let me refresh. You'll see there are more number of resources that are getting created. You'll see that. Virtual X machine extension takes a bit of time. It's going to take at least 25 minutes from my experience. So not sure it's going to continue. It's going to complete before we end this webinar. But you get the idea, right? You get these. If I go to the VMs, we'll see that I have the VM that is getting created. So I have these VMs that got created. Getting the IP address from the VNet, have VNet got created. There is a public IP. If I go to the Linux VM2, and it's standard B2, it has got the IP address. It was just created. Test Europe. Yeah. So I think almost all the resources it got created from what I see. And if you go to the storage account, it will see that a storage account got created. I'm not sure what is the name of the storage account. Let me see. 001. So 001. Yeah, this is the one. OK. And if you see that there are containers in the storage account. So data log script PS scripts. And within PS scripts, I have that PS script. Right. And this is what the VM extension looks at and installs that. That's what this is doing. Right. All right, this is the demo and this is a course outline I want to explain. So this is outline and like high level. We're going to look at a lot of topics within each topic. Subtopics we're going to look at in the each major topic. Yep, and that's all. Time for Q&A. Sorry if I've got some additional time, not giving time for Q&A. Please excuse me for that because I want to explain a little bit. So I took some time there. Yeah, we can ask anybody has any questions we can discuss.
Santosh, Raja here.
Hey, Raja.
Santosh, you said something about mutable and immutable in Terraform, right? So I don't get it actually. What exactly it is?
Yeah, I mean, see, so there are a couple of things here, a couple of views. One is you can create immutable resources, meaning you can create the resources, but you don't want to destroy them later for some reason. Like you can, there's a life cycle meta argument where you can specify prevent, destroy. So when you, it's like a lock. It's if you know resource lock, that's what it is. So for example, database, right? So let's say I have a database code in this code. right? And I'm executing a Terraform destroy. It's going to destroy the Terraform database altogether. The data is lost. So wherever you have data, you have your historical data or a state. Think of state. It's going to be stateful. So you will try to put a lock so that you don't accidentally, somebody should not delete it. That's one. The other view is the soft delete, right? Key vault. For example, if you look at this key vault, I cannot delete this key vault. I mean, I can delete it. It's going to be soft deleted. Uh, and I can't create a keyword with this name because it's already there. But I mean, it's there, it's not there. That's how it is. You can't see that in the portal, but it's soft deleted. So after 90 days, I have to come back and delete it uh, manually or through Terraform. So a couple of views there. So you can have immutable and mutable conditions. This is default. I don't have any immutable conditions here. It's all mutable. You can just delete the resources.
Okay. Yeah. So immutable means it prevents a destroy, right? So it prevents from the destroy.
It prevents destroy. Yeah. For example, I'll just show you. For example, let's say that for example, let me take an example of VNet. For example, I don't want to delete this VNet. Even Terraform should not delete it. So I could just use Terraform lifecycle and what is that? I think prevent destroy. This is the prevent destroy equal to true Boolean value. If I do prevent destroy equal to true, meaning this will be I mean it will not delete it.
Deleted. Okay.
Yeah.
So the life cycle, I mean the life cycle thing will not be deleted, is it? So it's kind of like that.
Yeah. When I put this nested block, it will not delete it. Because it will say, think of resource locks. If you know resource locks, I mean, I'm trying to give an analogy here. If you know resource locks in Azure, that's what it is. But this is Terraform, that is Azure. That's the only difference.
Okay. Got it. So, mutable means how we can differentiate from immutable. I mean, what immutable is?
It's nothing. I mean, you're just declaring that this resource need not delete. So that's what immutable means. I mean.
Okay.
Yeah.
Got it.
Yeah. So I'm just going back to the course outline because we know that we are in Q&A session. I'm just going back to the course line for anybody to look at just one more time. Any questions?
One more question, sorry.
No problem. Go ahead.
So for an example, it's like an Ansible, right? If we run the same script again, if there is no change, it's going to do nothing, right? I mean, for an example, if I create on file, okay, the file is already exist. But if again I'm going to run, it's not going to change if there is any change, right? But in the same way, Terraform also will do, right? I mean,
yes. idempotent. Yes, it's idempotent.
Right. So
yes, exactly.
So if you're not going to do any changes here, if you run again, any apply, any plan and apply, it's not going to change anything, correct?
No, it's not going to change anything.
Okay. Got it.
Okay, sure.
Thank you, Santosh.
Sure. Anybody else has questions?
Santosh, in the Visual Basic Studio, right? How did you get all these codes? I mean, how did you get all these codes? I mean, did you write manually?
I ran it. I created this code. I wrote these codes. Okay. Yeah.
Okay.
That's we should do.
Okay. So each and I mean wherever it requires a resource and all that we have to define manually for each resources and I mean in the TF form, right? So we have to.
Exactly. That's config file. That's where you have to define the resource block.
Okay.
Yeah.
So it will not fetch from your cloud, is it? I mean, we have to manually write everything, not kind of getting things from cloud and all that. So it will just not read the configuration of. I mean, if there is any existing configuration,
It will read. That's what state file does. If you look at state file, that's what, okay, it's logged right now because I'm running, it's logged, state file is logged. But yeah, it's going to read the state file. That's what plan and apply does. It's going to read the state. It's going to look at the state, match that with the existing resources in my environment, and it's
oh,
going to decide whether it's going to create, update, or delete.
okay, okay, okay,
That's right. Yeah.
okay. Thank you.
Yeah. Yeah. Any questions, team? Anybody has any question? The virtual machine extension takes some time always. I'm not sure why. I need to investigate why, but it takes some time. And with um, the network security rule, I know that RDP was allowed. I can directly 1395.95.118.40. I can directly log into the machine. That's going to give me a prompt. I can't put the password because password I don't know. You'll have to go to the key vault and fetch the password. Unfortunately, I don't have access to the key vault because I did not add myself into the access policies. So you will get a authorization error. But anyways, yeah, I should get the secret from the key vault and put that as a password. Any questions anybody has? You have some time left.
So even if you're planning to study the Terraform with Azure, you can do the same thing with AWS as well, right? So
Yeah. The
is it
concepts are going to remain the same, yes, but
same?
yeah, of course, the resource blocks would be different. The config is going to be different. Of course, Azure requires something else, but AWS requires something else. But the concept is the same. Our underlying Terraform concept is the same, irrespective of what is the provider.
Okay.
So focus is going to be Terraform plus a little bit of Azure, but not entirely Azure. Focus is going to be Terraform.
Okay.
Yeah. So yeah. Also, just a little bit, if you are looking for some training options for Azure, you can contact Credo Systems. Offensive penetration testing, AD attacks and defenses, um, cross forest, cross domain, Active Directory certificate services, general ethical hacking. You want to know? Um I take up the trainings there. Azure side, yes. Terraform, of course. Linux, yeah. So I think we are good. So any questions, you can reach out to Credo Systems team. They'll be happy to help. Um, If they can't answer, maybe I'll tell them. I'll provide the responses. They can pass that to you, or you can directly also reach to me. You can get my contact from the team.
Okay.